The universe is vast and mostly empty, a silent expanse stretching far beyond what our eyes can see. For billions of years, stars have been born and died. Planets have formed and vanished, and yet, in all that time, most of the cosmos remains untouched and unexplored by us. But sometimes, in the midst of this cosmic silence, the universe sends us a message, a sign that we are not as isolated as we might think. On October 19, 2017, astronomers in Hawaii spotted a faint point of light, an object moving too fast to be from our solar system. It was unlike anything they had ever tracked before, racing through the night sky at a speed that defied explanation. This was a traveler from the interstellar void, the first ever seen by human eyes and instruments. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. The name itself captured the sense of wonder and mystery that surrounded this discovery. For centuries, we wondered if objects from other star systems passed through ours. Oumuamua was the proof we had been waiting for, a tangible link to the wider galaxy. It was a physical piece of another star system, delivered right to our cosmic doorstep, carrying secrets from a place we may never visit. Scientists were electrified. This was a rare chance to study the building blocks of distant worlds, to glimpse the materials and mysteries that shaped other solar systems. Imagine finding a bottle washed ashore from an unknown land. You'd want to know everything about it, where it came from, who sent it, and what stories it might hold. Where did it come from? What journey had it taken across the stars to reach us? What is it made of? Was it rock, ice, or something entirely new to science? Who or what sent it? Was it a natural wanderer, or could it be something more, a relic of alien technology, or a message from another civilization? Oumuamua's arrival marked a new chapter in our exploration of the cosmos, not just looking out, but seeing what comes in, what visits us from the unknown. This tiny object transformed our view of the galaxy as a dynamic, interconnected place, where worlds and mysteries can cross paths in the vastness of space. But the message it carried was deeply puzzling, wrapped in layers of cosmic enigma. Every new piece of data only deepened the mystery, raising more questions than answers and fueling debates among scientists worldwide. Oumuamua didn't behave like anything we'd seen before. Its motion, its shape, and its lack of a visible tail all defied our expectations. It challenged our categories of comets and asteroids, forcing us to rethink what we thought we knew about the objects that travel between the stars. It forced us to confront the limits of our knowledge and consider possibilities once thought pure science fiction, from unknown natural phenomena to the faint hope of alien contact. This strange visitor had a story to tell, and it was up to us to decipher it, to listen closely to the message from the stars and let our curiosity lead the way. Our first clue that Oumuamua was unusual came from its shape. Unlike the round or irregular forms we usually see in space rocks, this object was something else entirely. Its brightness flickered as it tumbled, suggesting it was extremely elongated, like a cosmic cigar or a flat pancake. This rapid change in brightness told astronomers that Oumuamua was spinning end over end, revealing its bizarre proportions. This was unlike any asteroid or comet we knew. Most space objects in our solar system are either roughly spherical or potato-shaped, but Oumuamua defied those expectations. Its reddish hue hinted at organic molecules, tanned by cosmic rays over millions of years. This coloring suggested it had traveled through interstellar space for a very long time, exposed to harsh radiation. But when it neared the sun, it didn't behave like a comet. No coma, no tail, just a dry rock. Scientists expected to see gas and dust streaming off, but there was nothing. If it was icy, why wasn't it releasing gas and dust? This was a puzzle because comets heat up and shed material as they approach the sun, creating bright tails. Maybe it was a rocky asteroid, but that didn't fit either. Its motion and surface didn't match what we see in typical asteroids, leaving astronomers scratching their heads. The real shock, Oumuamua was accelerating as it left the solar system, pushed by some unseen force. This unexpected boost in speed couldn't be explained by gravity alone. No visible jets, no outgassing, yet it sped up, like a sailboat moving with no wind. It was as if something invisible was pushing it, but no one could see what. This contradiction launched a scientific adventure. Researchers around the world began to debate and investigate, eager to solve the mystery. Oumuamua wasn't just a messenger, it was a riddle. Its presence challenged everything we thought we knew about interstellar visitors. Science loves a good riddle. The more confusing the evidence, the more determined scientists became to find answers. Its combination of features was baffling. No single theory could explain all the strange observations from its shape to its motion. It didn't fit any known category. Oumuamua stood alone, outside the boundaries of what we thought possible for space objects. The mystery deepened with every observation. Each new piece of data only raised more questions, fueling curiosity and debate. The hunt for answers had just begun. As Oumuamua disappeared into the darkness, it left behind a trail of wonder and a challenge for science to solve. Let's talk about that push, non-gravitational acceleration. For comets, jets of gas act like rocket thrusters, altering their paths. But Oumuamua broke the rules. It accelerated, but telescopes saw no jets, no dust, nothing. The Spitzer Space Telescope found no trace of outgassing. The force was real, but its source was invisible. Scientists were left with an effect but no cause, a classic scientific whodunit. If it wasn't outgassing, what was it? The numbers didn't add up for any known effect. This stubborn fact opened the door to wild theories, from exotic natural phenomena to the extraordinary. Oumuamua demanded an answer. Was it a new type of object or something that would force us to rethink our place in the universe? The debate was about to get very interesting. When known explanations fail, scientists must consider the unknown. Harvard astronomer Avi Loeb proposed a radical idea. What if the push came from sunlight itself? He suggested Oumuamua could be an artificial light sail, thin, lightweight, propelled by solar radiation. This would explain its acceleration and strange shape, with no need for outgassing. Could it be a piece of alien technology, or even a probe sent to our solar system? The idea was electrifying, but extraordinary claims require extraordinary evidence. Most scientists remain skeptical, preferring natural explanations. Invoking aliens can be a trap, stopping the search for new natural phenomena. Still, Loeb argued we should consider the possibility, given how poorly Oumuamua fit any natural category. The debate wasn't just about one object, it was about the nature of scientific inquiry. How open-minded should we be? Oumuamua pushed these questions to the forefront. While the alien probe idea grabbed headlines, other scientists sought natural explanations. One leading theory, Oumuamua was a nitrogen iceberg, a fragment from an exo-Pluto. Pluto and Triton have surfaces of frozen nitrogen. If Oumuamua was made of solid nitrogen, it would sublimate near the sun, providing a gentle, invisible push. No visible coma, just a ghost engine. Over millions of years, cosmic rays could have eroded it into a thin, pancake-like shape. This theory explained its composition, acceleration, and shape. It suggested Pluto-like worlds might be common, occasionally shedding fragments into interstellar space. If true, Oumuamua was a sample from a distant, icy world. No aliens required, the universe is creative enough. A nitrogen iceberg is wondrous in its own right. The nitrogen iceberg theory faced scrutiny. Solid nitrogen might be too fragile for a long interstellar journey. This led to an even more exotic idea, a hydrogen iceberg. In the coldest parts of space, hydrogen could freeze into solid chunks. A hydrogen iceberg would sublimate easily, providing a powerful, invisible push. But could such icebergs form? And would they survive the journey? Many astronomers doubted it. Hydrogen ice is even more fragile than nitrogen. Each natural explanation solved one problem but created another. The debate between nitrogen and hydrogen icebergs showed how challenging this puzzle was. Science is about proposing, testing, and refining ideas. Oumuamua left us with no single satisfying natural theory. The mystery remained unsolved. The story of Oumuamua is about how scientists grapple with the unknown. Some favor natural explanations like the nitrogen iceberg using familiar physics. Others argue its properties are so unusual that we must consider radical possibilities, even alien technology. The debate is healthy, it sharpens arguments and pushes for more evidence. But we're stuck with too little data. Oumuamua was already leaving when we found it. Its brief visit left us with more questions than answers. The legacy is profound. It expanded the search for extraterrestrial intelligence to include physical artifacts. It spurred new theories about planet formation and interstellar objects. Oumuamua was a cosmic wake-up call. The universe is full of surprises. The debate will only be settled when we find the next one. The idea of alien technology is thrilling, but science demands skepticism. Extraordinary claims require extraordinary evidence, and we don't have it. Oumuamua's strangeness is not proof of artificial origin, just proof that it's strange. History shows that mysteries once attributed to the supernatural were later explained by science. Oumuamua is likely a new type of natural object, not alien engineering. That discovery would be spectacular in its own right. We shouldn't dismiss the search for alien technology, but we must be rigorous. The burden of proof is on those making extraordinary claims. Right now, the alien hypothesis is an argument from ignorance. We need positive evidence, radio signals, metallic composition, something unambiguously artificial. Until then, I remain open-minded but unconvinced. The universe's imagination is vast, and the next messenger may hold the answer. Oumuamua's visit in 2017 didn't just surprise astronomers, it opened up an entirely new field, the science of interstellar objects. For the first time, we had direct evidence that objects from other star systems could and did pass through our own solar neighborhood, sparking a wave of excitement and curiosity across the scientific community. Before this discovery, the idea of interstellar visitors was mostly theoretical, something discussed in textbooks and late-night debates. Now it's become one of astronomy's hottest and most rapidly evolving areas, with researchers around the world racing to spot the next cosmic traveler. The discovery of Comet Borisov in 2019 was a game-changer. It confirmed that Oumuamua wasn't a fluke. Interstellar visitors are real, and they might be more common than we ever imagined. The goal now is clear. Find more of these mysterious objects and find them as early as possible so we can study them in detail before they speed away forever. New technology like the powerful Vera C. Rubin Observatory will soon scan the entire sky every few nights, making it possible to discover dozens of interstellar objects every year, each one a potential messenger from another world. With a larger sample, we can finally start to answer some of the biggest questions. Are objects like Oumuamua rare, or are they actually common visitors to our solar system? Are most interstellar travelers icy like comets or rocky like asteroids, or do they come in forms we haven't even imagined yet? This is galactic archaeology, studying physical pieces of other solar systems and unlocking secrets about how planets and stars form across the galaxy. Some space agencies are already designing rapid response probes, ready to launch at a moment's notice to intercept and study new interstellar objects up close. Imagine the possibilities: getting up-close images and direct analysis of another Oumuamua, revealing its true nature and origin for the first time. That's how we'll finally solve the mystery, by bringing the unknown into focus, one visitor at a time. Oumuamua was just the beginning. The hunt for interstellar objects is only getting started, and every new discovery brings us closer to understanding our place in the cosmos. The secrets of the stars are waiting to be uncovered, and the next great discovery could be just around the corner.